Well, hello. This video is going to help with properties of parallelograms. It's section 14.2 for course 1. And so I'm going to go over basically the theorems, and then we'll look at some problems with them. So the definition of a parallelogram is that opposite sides have to be parallel. So in this picture, we represent parallel with like double lines for these two being parallel and single, or not lines, but arrows this way. So that's kind of the symbol for parallel. So that's our definition. So here's all our theorems about parallelograms. So theorem 40 states if it's a parallelogram, then opposite sides are congruent. So you have to know it's a parallelogram for that, right? Then theorem 41 says if the opposite sides are parallel, then angles next to each other add to 180. So I listed them here for you. So it's like A and B add to 180. B and C add to 180, C and D add to 180, and D and A add to 180, which is going to lead us to the next theorem that says these two are the same. So basically, if they're next to each other, they're add to 180, or if they're across from each other, they're going to be congruent angles, and that's the next theorem. So we know if this one's, and these two are adding to 180, and then these two are adding to 180, then these two would have to be congruent. So you can actually prove that, but that's our next theorem, is that those opposite angles are congruent. If it's a parallelogram, opposite angles are congruent. Another one, if it's parallelogram, then if we have our diagonals, they're going to bisect each other. And so what's the definition of a bisector? They're going to bisect each other. This one will be congruent to this one. This one's congruent to this one. So however you want to state that one. So these are all of the theorems. I thought there was one more theorem, but maybe not. Oh, there is, and I'll go over that in a second. But let's look at what we would see for example problems that are similar to this. We're going to see something like, all right, if this is a parallelogram, so you have to be, either it has to have the symbols or they have to tell you. Then if this one's 72, what's x? Well, you know, they're next to each other, so they have to add to 180, so it would have to be 108. So you might see a problem like this, but again, it's going to have to tell you that it's a parallelogram or show that opposite sides are parallel. Now, number 2 here, I am stating that this is a parallelogram, so opposite sides are parallel. Find x and the length of each side. So what would x be? Well, there's 2 ways that you can find x. So I'm going to scroll this in a little because it's kind of got a shadow. Or maybe if I move it up, it's going to be as ugly. There we go. Okay, so you can find this 2 ways. You know that this side has to be congruent to this side, so you can set up the formula that way. So x minus 3.5, that's a 3.5, is equal to 18.5, and you could see that x is 22. Or, you know, these two are equal, so you could have set those equal to each other and solved and also got 22. Then what you can do is you can plug those 22 back in to find the side lengths of each side. Well, this one is going to have to be 18.5 because we already know one of the sides. And then the other two are congruent. So what's 22 plus 1.6? Well, that's 23.6. So these sides are both 23.6. And you could double check this one and make sure, and it does work out. So you might see some problems like this dealing with congruent sides or congruent diagonals and similar problems to that. The next theorem is theorem 44 in your book, is going to state that, so it says if you have 3 lines that are parallel, and they're cut by transversals where 2 sides are congruent. So this is the same length and all 3 are parallel. Then we know that the other sides on the other transversal are congruent. So if then, we can assume these other 2 sides. All right, so let's look at what we would see for an example problem for this one. So I've already worked it out over here, but if we see this, so we have 1, 2, 3, 4 parallel lines, and we're given that EF, FG, and GH are all congruent. So these are congruent, right? They're all equal to 6. We're given that. And we're also given that AD all the way across, AD is 15. What is CD? So one of those. So we know if we have congruent on one transversal, the other transversal also has to be congruent by our Theorem 44. And if we know the whole thing is 15, how many pieces is that in? 3. So we can just divide 15 by 3 and see that each side would be 5. Okay, so that's kind of what you'd see. This one I thought was a little confusing because the drawing was a little different, but you might see something like this too. Well, my drawing doesn't look very congruent. This one looks way smaller than this one, but if you know these are congruent and you have 3 parallels, then we also know these are congruent, and if one's 5, what's the other one? 5 also. So those are the types of problems you're going to see in this section. Basically, you just probably need to write out those theorems in your notes so that you remember them and can look them up. All right, let me know if you need help.